So, welcome, students. This is John Hanacek, who I met recently um, through Susan Ibjul at the Mars Academy USA, and discovered that John was working in mixed reality. And I thought this would be a good opportunity for you to see real mixed reality development since you're stuck at home and can't get your hands on the HoloLenses. John is the co-founder and CEO of Avatar Medic. He has an MA degree from Georgetown University in Communication, Culture and Technology, and he has a BA degree from UC San Diego in political science. He's also a first responder, has worked as a beach lifeguard in California state parks. John has extensive skills and experience working in foresight, strategy consulting, user interface and user experience design, videography, computer graphics and spatial computing. John's an entrepreneur and a leader, has co-founded a buildings materials solution startup and brought products to market. His passion and drive is to make ideas tangible, actionable and sustainable, and positively impact billions of lives through technology solutions. And today he's going to show us some of the technology he uses at Avatar Medic. All right, thanks, John. You can begin.
All right, great. Well, without much further ado, I can show you all one of my favorite little demos. So this is going to be a very demo-filled day. For some quick background is that Avatar Medic is, to talk about it quickly, is a company building basically this. I'm going to try and be as visual as I can. Right now, you've got telepresence in hospitals, but it's done via screens, via little tablets. So we want to actually make a robotic surrogate doctor. This is one of the hardest challenges anyone can do. There's a X Prize to do this, and we've assembled a pretty powerful team in order to do this. And building a robot actually has a lot to do with spatial computing, or sometimes it's called VR or whatever. But the core technologies that are inside of these headsets are really important to robotics, both from an interface side and from an actual technology piece. The way that these headsets see the world and the way that robots see the world is actually really similar. You guys I don't know if you've got to the SLAM part of your understanding or education yet, or you may already know the simultaneous localization and mapping, where these things know where they are. That's also how robots know where they are. So I'll get to that in the end. I just got my robot demo working before this class. This is the robot behind me. And I'll be able to show you briefly some of that. But I want to start by kind of starting where I began moving from 2D stuff to then when this Magic Leap came out, I really moved in earnest to working with this technology. I care a lot more. I'm just going to be up front. I care a lot more about this kind of pass-through augmented reality, but that's not really enough, right? To specify this is a spatial computer, so that, what you see on my little brush here, VR, we cover up the whole view. AR, it's a layer in front of what's going on. And then a spatial computer is, there's actually some understanding of the volume of space. I think my diagrams I try to use this technology to explain things while talking. Let's see if I can make a little 3D. There you go. So in the headset, this is in 3D, and this is an application called Spatiate that is really helpful for designing these types of things, because I'm sure you've all encountered the reality that when you try to make something 3D, if you're using a 2D tool, you're going to run into a lot of assumptions that you had when you try to make it into 3D. So tools like this are really exciting, because right now, actually, the camera that's streaming this is an iPad. And so you can interact with this kind of mixed reality drawing application, where I can go around and I can block out, like, here's the window should be here, and maybe there's another window here, and then maybe there's another window here. And you and I can share this if we join a multiplayer zone, and you can even use stuff like the iPad. So although these headsets are really cool, they're not actually required to begin thinking spatially. There's also another iPad app called Torch that I like to use a lot. So This session is intended. I wanted to give you all some demos from the design, more of the design perspective. I'm not going to get too deep into Unity type of stuff. I'm more talking about how do you conceptualize a 3D interface? How do you think about how to make things in 3D, given that we have these tools available to us? And also, I hope that I'll be able to field some questions from you as I try to go inside my purple boxes, right? You can make interactive stories in real time with these kinds of things. So I'm hoping I'll be able to field some questions too. So it's sort of funny world that we live in where you're all out in the Zoom world or you're in the Microsoft Teams world, and I'm here. And I can actually show you what I'm seeing from the other side, because this has been a funny time for me, because I have access to all these technologies, but looks like this one doesn't want to stream unless it's plugged in on USB. I have access to all these technologies to let me be an avatar, and it's a lot more interesting way of being than these 2D things. But I've had to learn, and this is something I want to kind of explain to you all and give you some strategies, is how do you bridge the gap if you have the 3D technology and you're the designer or you're the engineer? How do you enable someone else to see what you're doing? So you can kind of see that, hopefully this is somewhat understandable, where if I'm able to draw this way, you can also see it here. You're able to see more of the interface. You're able to see that there's a little iPad avatar that is present down here, so that this session is networked. So this stuff is really exciting because a lot of the challenges that we face building these systems, again, are inherently spatial. They're inherently about how many times can you do a motion before it gets uncomfortable. They're about the arm length, distance. They're about understanding space around you. So the sooner that you can get into these kinds of tools, the better. So I don't know if there are any questions, or if you're all just, it's my nighttime here and it's your, or not my nighttime, it's my evening here and it's your morning there. So just let me know at any time if there are questions that come up, because as I jump around to these demos, you'll have to forgive me for being a little bit all over the place. But I really wanted to be able to engage with you all in this demo way, instead of more of a
Tung has a question, way. John. One of our students, Tung, has asked, what is this device? So that they've seen the HoloLens, but they haven't seen this device before. This is the Magic Leap, right?
Yeah, this is the Magic Leap. So that's a great question. This one, it's very similar to HoloLens. I have a HoloLens. I'm going to switch to it in a moment to do a spatial demo. But this device came out about, so HoloLens, I'll draw a timeline for you. HoloLens 1 came out, and then the Magic Leap came out. Oops. HoloLens 1, then the Magic Leap, and then HoloLens 2 came out later. So the Magic Leap kind of sits in this middle space where it has some hand tracking, but it's rudimentary. So it's more advanced than the HoloLens 1, which didn't have any hand tracking, and it's a little less advanced than the HoloLens 2, which has really robust hand tracking. But it does have this unique element, which is a controller, which, as you can see, kind of gives it a chance to be more of a gaming system. And if you guys want to see, guys and gals want to see more content from the Magic Leap, it actually has quite a large library. And what I'm going to do is actually switch between the headsets. I think maybe I'll go ahead and just do this now and give you a real life context of a project that we just finished, where we blocked it out or prototyped it. The target was for Magic Leap, and I actually blocked it out and prototyped it on the HoloLens 2 because it's a little easier to wear. You see with this has a NVIDIA Tegra chip in it. It's kind of a funny computer. You have to wear the computer part, and then it goes into your head. Whereas the HoloLens, you can just wear it as it is. The Magic Leap is also, I think, $1,000 cheaper than the HoloLens 2. These HoloLens 2s are expensive things. And I'm going to focus today primarily on these types of devices because it's where my usage is more. I wouldn't call myself a VR expert per se. I think of myself more as a spatial computing expert because I care about solving problems for people who operate in the world. So they need to pay attention to their surroundings. So the Magic Leap is like the HoloLens in that it's a waveguide. So it's overlaying images using a waveguide. And I'm going to pull up a quick little surreal sort of demo here where this is a solution that is called Spatial. And I'm going to jump into a real life room. This is an example of a room that we worked in to develop a system. And then I'm going to jump back over to the Magic Leap and show you what we developed after this. So hopefully you're able to understand what's going on here as I share this content in this way. And this is also how, as a designer, I was able to talk to people who only had video access and they couldn't actually join me inside these technologies as they didn't have access to them. So how do you connect the dots and you give someone the context of what's going on? So here we go. So I think I'm going to see. Am I going to pull myself up here? Come here, little buddy. I should be in here. This is an interesting solution. This is called Spatial.io. And there we go. This is networked. I could probably give you the link to this later if you all wanted to enter this room. But I'm going to show you two things. I'm going to try and show you the other side of this. And this is what I did in a real life design session where I streamed out. Here we go. So we're getting the multi-split screen here. This is actually probably the best implementation I've ever done of this, where you're going to see the content that's through my first-person view alongside a camera. It doesn't show the content from third-person view. As some of you may know, that's really difficult to do in today's era. I'm just going to make sure this room position is better for us to see everything. And I want to talk to you all about a project that my team and I just finished, which we called Augmented First Responders. And this was in the United States, there's an agency called NIST, National Institute of Standards and Technology. And they had a prize to make interfaces for first responders for different scenarios. One of them being wildfire, which I'm a Californian, you all are Australians. I think we probably share a little bit of a common bond here with how much we have wildfire problems. So we wanted to tackle that. And so what you're seeing here is, this was our earliest prototype space, where we used Spatial, and you'll see my little avatar over here, and I showed the team through first-person view, and we needed to design two components. We had to design a hologram type of a system. So this is kind of your sci-fi hologram, and then a heads-up display. And I will show you the output, the actual software that we developed for Magic Leap. So again, using these tools, you can use different pieces of equipment to all come out to the same thing. And maybe some of you already know this, but I think it's worth noting that this Spatial tool, Spatial.io, is free right now, and it works on the Oculus Quest. And it also works kind of on the desktop. You can see it sort of works, but you can't interact other than you can add content to these spaces. So this became really important in our development because we made a two-dimensional concept. and we made some materials, some kind of 3D graphics materials in the 2D world of the computer screen. But then we needed to figure out if some of our assumptions would actually work. So for example, this object over here was an early test of what would it look like to overlay actual mesh geometry over 3D, a 3D graphic of actual from Google Earth that we grabbed in from Blender. So right away it starts to become overwhelming, and this didn't look as overwhelming on the computer screen. In here it looks really intense. So what we needed to do was discover, how do you make a map useful in 3D? And so we used, this is an actual fire map that we made geometric, and I was able to experiment really quickly by just pulling in the shapes with what's going to work. Is it going to make sense to walk through a map? Is it going to make sense to have another map in the background? Where you can see some of our notes. A lot of these features didn't get implemented entirely, but we still have the notes for them. And if any of you have come from a 2D UI or UX background, which is where I came from, it's the next dimension of it, right? You're going to have your notes, you're going to have your wireframes effectively. And this helped us with a lot of different assumptions that, like I said, made sense on paper. For example, the legibility of the map, one of the earliest design ideas that we had was to say, if there are icons that are on this map, we should overlay them in 3D. So for example, one of them is, can my hands? One of them is this little break, this division break symbol. It's the symbol that goes to denote whose jurisdiction in the wildfire scenario is responsible for who, where does it end? So here you can see one on the map. Quickly, I then made this 3D model, right, and put it in to see, okay, what would happen if we actually overlaid it over the thing? Because my assumption was, we should try to have 3D icons for our 3D map. But pretty quickly, what I realized is that actually, if you have 3D icons, you occlude parts of the map. And this was something that, maybe some of you are smarter than I am, but for me, this was important in the design process. The entire team, using a method very much like what you're seeing right now, we all gathered around this, and I explained to the programmer and to the other designers that we were going to need to take a different approach with our map. We weren't going to be able to just throw 3D icons on it willy-nilly. We were going to have to be careful, because we could end up making a map that was harder to see, while also sacrificing the fact that, I hope you can with this, that the terrain is visible. So this kind of technology gives a new perspective. And when we showed this to wildland firefighters, they were pretty excited about the idea of just getting to see the landscape. So we really wanted to go with what was working in the interface and what wasn't. And so we were able to show this using Spatial before we wrote a single line of code on a headset project in Unity. We had made a simulation project in Unity that was a sort of a first-person controller 2D game, or in a 3D environment, but it's a 2D output. But this gave us a chance to actually test some assumptions then in the headset without needing to build anything. So that was very helpful. So this kind of talk of mine is going to try and connect the dots here between these. And look, we can see my head gets all scary in there, right? That's funny. So this is obviously the most powerful headset, the HoloLens 2. It's really easy to wear. You can wear it with glasses. So I use this to do the design work, but our output was supposed to be the Magic Leap. So now I'm going to boot up the Magic Leap, and I'm going to show you the output from that experiment. And I can't show it to you from the side or anything, other perspective, because I can only show it to you through the face. I don't know how to say that, through the heads-up view, the headset view, because implementing a third-person view camera is really difficult. You end up having to make an entire networked scene, and this was meant more as a prototype for the concept. So I'm going to show you. Here we go. You can also see the interface of the Magic Leap. They tried to make their own little interface here. And there are a lot of interesting apps for Magic Leap. If you can get one of these on your head, it has a lot of insights into it. And I would actually love, after I show this demo, I'd love to open it up again for questions about if anyone has been trying to design things and they want to know some good practices, or if they just want to ask other questions about how to get started, particularly with this type of design, because making these kinds of interfaces, as you'll see when it loads up, is different than making a VR interface, because you're not replacing reality, you're adding something to it. And you're not just overlaying something on video, you're actually placing something in this physical space around you. So what you hopefully should be seeing is a sort of front circular map and a large back map. Now, I hope that you'll notice that there's some similarities between this and that kind of rough prototype room that I showed you before, but we've obviously refined it considerably. And one of the things that came out of us working in that other room was we had to say, all right, well, we're going to need a better way to manage this map. It gets a lot of information on it. So you can turn things on and off. You know, in this case, you're showing the burn area of the fire. We're showing humidity. But on a 2D map, all this stuff has to stay flat. But in 3D, it doesn't. So we developed this concept of elegantly, well, we think it's pretty elegant. It could, I'm sure it could get better, but expanding the map so that you could actually have a chance to look at things in their context, but not lose where they went. And we even enable the user to kind of make their own adjustments of this if they wanted to leave it. But when we collapse it again, it goes back. And when we expand it again, it resets. So this serves the incident commander, as they're called. And so the kinds of software that obviously I'm making, this is made in Unity. So it's just a normal Unity project. But our purpose is not a game as much as it's, well, the game is keep everything from burning in the real world. So my interest and my research and my work with my team is to make things that are for the actual usage by real first responders or medics. So this represents a prototype of being able to, instead of having a couple iPads or some TV screens, being able to have a map of any arbitrary size and being able to kind of walk around inside of whatever incident is going on. Little touches were added. What's really interesting about these types of headsets is, unlike VR, you're about a half the field of view of VR. So VR, as you all probably experience, is like 100. Well, I'm not sure if every single one has been in a VR headset yet. I don't know how far along your class has been, and it has been some gnarly times. But for everyone who's been in a VR headset or not, you're looking at a field of view of like 100 and some degrees. So your eyes are like 180 degrees-ish. That can see kind of all the way to the edge. A VR headset gives you kind of like this. Whereas these, what you're seeing right now through the screen on the other side there, that's the field of view of the graphics. So although you can see more around you a little bit, the graphics are only about a 50-degree field of view. And that's on the Magic Leap and the HoloLens. They're very similar. And that's pretty much the standard for these types of headsets. The other HoloLens one was like looking through a straw. It was even smaller. So what that means is you have to be really careful with how you make these things, because you can make things that are as big as you want, but you can't see them all. So as you see, I have to scan around. So what you end up, there are some little tricks that I've been finding, and there's a lot more that we're going to need to find to work with these interfaces, where, for example, try to make things track with the headset so that you're able to keep more in view without needing to move your head around. So if you notice, there's a little tiny turn here. That means I don't have to complete the full turn to the left to get to the left information. I don't have to complete the full turn to get to the right. It's trying to meet me a little bit where I am. So you have to keep things a certain size. You have to keep things, at kind of arm's length reading distance. And it's a very kind of a fun challenge. We got through as far as the phase 3 of this. They're currently doing a phase 4 where other teams made more interfaces. We had to move on to other projects like working with this robot. But this was a great experience for us to connect the dots between some of the ideas that we had in terms of using these types of technologies and actually implementing them. So I'm going to show you now, there was also the heads-up display component. And this component, while it loads, I'll explain that designing a heads-up display is interesting because you can do it a lot more in 2 dimensions, because it's, in theory, just a flat plane that's overlaid, a heads-up display. But it still has depth to it, and it has other features. So hopefully you'll see now in the right side of your screen what this is. It might be a little hard to see. It gets a little cropped, but in the top, there's a compass. There are markers that are placed out at distance. So that, for example, my eyes view that as being far away, which is a weird phenomenon because I can see a wall right there as well, which is also what's really weird about this technology is you have to really be able to, well, as a developer of this technology, you need to be able to handle really weird eye focus, if that makes sense. Like I've had a lot of times where I'm looking through my wall at something and you just get used to it. After some time, you just get used to it. And this interface was really cool because this was the first time I had ever implemented eye tracking in a functional interface. I've done experiments with it, but this, we actually implemented eye tracking. So I'm not sure if you can see it, but there's a small cursor that represents the real-time position of my eyes because Magic Leap and HoloLens 2 both have eye tracking. And so I'm going to walk you through a couple of the design choices that we made here in order to achieve this heads-up display. So this is also for a firefighter. And there are certain things that a firefighter needs to know. They need to know they might have a command. They might have some information. They have their own personal information, and they might be wearing a breathing device. So they need to know how long they can stay out in the field. And it's good if they know certain characteristics around them, like how humid it is, what the burn index of their area is. But it shouldn't overwhelm their view. So we want to make sure it goes away when they're not looking at it. And being able to access the weather is also helpful. And this one requires some refinement. You can see that designing for eye tracking is really tough. You need to develop more smoothing systems than you might think because the raw data can get pretty jumpy. So as you see, I try to get it to hold on. So this was a great experiment for us. Now also you notice up here, we implemented then to turn on and off this layer. This represents data layers that are out in the world. So although these look flat, they're out at distance in space. That's how I see them. And then you can place markers on the space, such as these, and they would then get added to the overall incident command map that you saw before. But we realized that turning this interface on and off was happening all the time just by people looking at it. So we had to put in a little smoothing kind of a system, a very simple thing of you need to have your eyes linger on the target for, I think, let's see how long it is, a couple seconds. And that helps cut down on the accidental eye gaze. So you see now I can move around and I don't accidentally trigger that. I have to be very deliberate. So this was, once again, a great experiment for us to be able to say, would it be overwhelming to have a heads-up display? So in a way, we're underutilizing this computing technology because this computer is 6 degrees of freedom, but this heads-up display always stays right with us. But I think we're utilizing it right at its capacity because these markers are spatially located. And this was an interesting one, and I'll conclude, and I want to open it up for some questions now before I do maybe another demo and talk about some tools that you all can use. Yeah, go ahead.
John wanted to know, What parts of this user interface follow you as you walk around, and what parts of it are fixed in space?
Yeah, good question. Let me explain that when you have these kinds of 6 degree of freedom computers, this one, when we say it's a heads up display, everything, this compass and all these things are basically anchored to my head. So I'm going to try and move around without making you all sick, because I also know that it's a big difference between seeing it in the headset and seeing it on the video. So this, as I move around, I can't walk around because unfortunately I need to stream this over USB, but try to believe me that if I were to move, this always, if you notice, it always stays a fixed distance from my head. However, these little markers are spatially located. So if I make one right here and I move around, they're the same marker, but it's spatially located. And we combined that spatially located aspect, and then we compressed it down onto the compass on the top. I'm not sure if you can really see it, but all these dots represent headings to one of those points, but they're collapsed. So this was an interesting challenge because building something for a first responder working in the field, they don't really have time to look for things. They're trying to be shown where things are. So that's why you need to have this, some information is always following them, but some information really does exist in the world, and they're trying to figure out what that is. So for example, if I encounter a hazard, it's here. The hazard is right there. It should be spatially located, but I should be able to know about it also in a flat sort of way. I hope that helps answer the question. Is there any others?
That's great. John, I noticed similarities in your heads-up display to what I was looking at when I was designing a VR heads-up display for my helicopter game, which was that most of the information the user wants to know is really just a number. It's not a three-dimensional piece of information. They want to know their altitude or their heading, and those are just scalar values. So I found that even though I had the ability to place values anywhere in 3D, what was most comfortable for the user was to take the traditional heads-up display and put it in a sphere around them. Put it as projected. Really, the only information that I thought needed to be 3D was their velocity, because it had a depth component. And I thought it's very interesting how you've taken the same approach. You've found that only things that really need to be spatially anchored, you put them with some depth. Everything else is really on a kind of a curved screen around the user. Do you find that's just what can I ask, what distance do you put your numbers? What distance do you find is easiest for people to read?
This is a good question. It sort of depends on the technology. The Magic Leap has a weird phenomenon where, let me see if I can simulate it for you. If you get something too close to the Magic Leap, there it goes. It has a clipping plane. So you can't put things very close to the user in these types of technologies. The HoloLens 2 lets you go super cross-eyed, and I love it, but it also lets you go super cross-eyed. So we found basically that you need to make your text, this is not a hard and fast rule, it's more of a rule of thumb, but we find ourselves, and then also in the literature, there's this idea of you're going to place the text a little over, you can kind of think of it like a little over an arm's length away, like it's a screen you're looking at somewhere ahead of you, and you need to make all your fonts big enough to be readable as though they're slightly farther away, because if you bring it too close, even like an arm's length away, can feel sort of oppressive. Like it can feel like things are falling onto you because they're right near your face. So you wanna, and it's a weird feeling. It's like a very unconscious sort of feeling. It just feels bad when the things are too close to you. You wanna make sure they're a bit further away. It's a bit tricky though, because if you have to wear glasses and you put the text far away, it will render blurry. If you're like me, I have a slight nearsightedness. So when I put the text too far away, it's harder to read. So there's a trade-off present, and I think that's why I say it's also about the technology, because I think future versions of the technology will either, like HoloLens, enable you to wear your glasses while you do it, but increasingly I think they'll be able to adjust to your various vision needs with sort of electronic lens elements and things, and not need that. But for now, think about putting it kind of out there. And then that's where I say, you just have to kind of get used to, like here, I don't know if you can see, there's a chair there, and the text is flying right through the chair. So that can be a little disconcerting for people at times. I'm just going to give my headsets more chance of finding me. But I think it's great you bring up this idea of like some things need to be in 3D and some things don't. And that's kind of hard to, this goes back to my point earlier of it's really important to test things, because right now in the industry, we're still building up all these rules. So there isn't a good, this kind of data should always be 3D and that kind of data should always be 2D. You have to really make sure that you try it out. So if there's a value in doing it, you should try and find that sooner than later, or else, like I was talking about earlier, if there's a problem with doing it, you should try and find that out sooner than later, especially before you go make a bunch of 3D models, because it's a lot harder than making two-dimensional elements. But I will say that it's important to try and avoid doing a lot of flat text inside these headsets, because although it's not easy to see on the 2D screen here, when you're in the headset, you can really tell when something is flat or not. So for example, these elements, and there's a trick that I think is an essential required trick. If you're going to use a 2D element, you need to make sure that you can never go to 90 degrees of it. And so the reason for that is you should never be able to make your element invisible. And I hope you understand what I mean. So I'll give you the example of, you see this icon on the ground has a simple rule. It's always trying to face us, but it's a flat sprite. So as you can see, whenever I look at them at any distance, they're always facing me. I can't get too close to this thing and make it go to the side, because what happens, it gets really frustrating for users when you have a flat plane in your game, or your especially these kinds of interfaces that are for use, and the user can get to the side of it, then they can make it invisible and they can't read it. And it's really hard to read things that are at an angle in VR, and especially in these types of spatial computer headsets, because the pixels it's not enough resolution. So it's not like looking at a screen from the side, you're looking at a rendering of a screen. And so it's a good pro tip to always have everything if you use 2D things, try to always have it face the user, AKA the camera. Yeah, that's a pro tip. Does anyone else have any questions? I want to also show you, I'm going to show you all another demo too, of the mixed reality toolkit, because I want to make this a little more tangible of like, how could you all get started building something in Unity? But I'm going to show it to you in the context of the headsets. But does anyone else have any questions about this?
Yeah, we've got one more question from Joshua. Okay. He wants to know, do you feel the technology you've demoed is ready for use in the field, or do you feel like you're prototyping for a future when these could be deployed?
That's a great question. And the answer is, heck no, this is not ready for the field. This is totally prototype for the future. So as a startup, we're going after investment. We're going after the future, right? Many technologies that we're wanting to work with here are not mature at all. In fact, it might be interesting to take a quick diversion into, let's see, what's a good example I can give you of the meshing technology? Excuse me. These headsets require a pretty stable situation in order to work. I'm trying to see if there's a demo on here where I can show you. But these headsets are very brittle. If you try to walk around, for example, out in the field with one of these headsets on, it will lose the tracking of the ground, because, well, you have to basically look at the ground the entire time so that it establishes a plane of reality. Because these systems, they basically mesh the reality. And I'm not sure how familiar that the class is with this idea of a scan, of a mesh, or the SLAM technology. But I'll tell you, hopefully you can see here, here it is meshing the space. So this is what the Magic Leap sees. And this is how it situates me in the reality. And this is how it places objects in context. So in order to use this in the field, it needs to get better. But that's the reason why we use the heads-up display paradigm, is because there are other headsets like Google Glass, Vuzix Blade, there's an Epson one, there's a handful of others that are already deployed in factory type of settings, because they don't try to figure out where they are. they're not a spatial computer. So Google Glass is not a spatial computer. It doesn't know really very much about where it is. Whereas the Magic Leap knows precisely how far away that point is from me, the headset. And if it loses that precision, then it falls apart. Then the thing says, in fact, maybe I can make it give an error for you. Wait, let's see if I can make it get scared. It'll lose its head tracking. But basically, oh, it's doing a good job today. So basically with these types of technologies, it needs to know where it is. So if you want to deploy something in the field, you need to use technologies that don't care where they are, but that's effectively the same as holding a phone in front of your face, right? You could maybe do some computer vision with it. You maybe know about the gyros, but you're not yet able to understand exactly where you are. So our horizon for being able to actually put these things in the field is a little further ahead because the Microsoft HoloLens is being deployed pretty heavily by the US military. They're very interested in using the HoloLens too. So we're hoping that will help accelerate the pace of these technologies getting strong enough. But right now, if you try to use these in different lighting conditions or you try to walk around with them, they'll lose where they are. They won't understand where they are, which is sort of funny. I hope that answers the question.
Yeah, John, I had a similar experience developing an app on HoloLens, which would allow the user to walk around a library and get a tour of the library. And what we found was that it worked fine as long as the developers were using it. But when actual customers went to use it, tracking errors would cause them to give up very early.
Yeah.
In other words, the technology is very useful for an experienced developer because you're willing to forgive the glitches. But if you give it to an untrained consumer, glitches are totally unacceptable and they will quit. We have another question from Benjamin. Have you found any use for 3D text as opposed to 2D text in a 3D space? So it seems all of your user interface is really 2D components placed in 3D space around the user. Do you ever use 3D text?
Yeah, that's a good question. I think you're hinting at a question that's kind of right at the tip of a lot of people's systems. So, not just us, but a lot of other systems I've noticed, they just use effect. Like, for example, this is Microsoft HoloLens interface. It's just 2D text. There's no extrusion to the text at all. And so far, what I've found in my research is that if you try to make the text extruded, what's the right phrase for this? The cost benefit isn't good enough. So the value, the value that you get out of doing that isn't really enough to make it worth your time. And I'm trying to find there's a thing I have called, I think it's called Type in Space, and it literally can help us play with this idea, but I guess maybe I didn't download it yet. Where you don't really need your system to be, so actually check this out. This is kind of a good little demo that we can actually think through right now ourselves, which is here you have some 3D text. This is an icon for the Mixed Reality Toolkit that Microsoft provides. And if anyone's not familiar with the Mixed Reality Toolkit, this is what I'm going to show you next. This is full of a lot of really great leads for building projects. And this has become my go-to design toolbox. But to help answer this question, let's just take a look. At what point is the 3D helping us? And at what point is it hurting us? So for example, if you can see here, you've got a clear view of what this icon is. But if I this is what I was talking about earlier, when you go to the side. Now, if I go to the side, I can still make this icon completely useless. Can anyone tell me what this says? I have no idea what this says. So making it 3D alone isn't going to be enough to help you. In fact, you can also see that without the right shading, the 3D can become even more confusing than simple 2D, where here you're seeing that this back part is occluding, or they're covering each other up. So now what used to be clearly MRTK, well, it's harder to see. Oh, okay, R, I need the difference inside there. So this is a frontier area, and that's why I think it's really important for everybody to actually test these things out. Like, for example, you could imagine making this into a bevel, but would that really help? More useful would be likely to be able to make sure this thing always faces us. right? Rather than trying to make something 3D. Or you could try to make it 3D, but it needs to be a shape that's going to survive being looked at from any side. And I hope that makes sense.
Thanks, John. That's all the questions for now.
All right. So what I'm going to show you guys now is a really cool. This is not something I made. This is something available to all of us. It's the MRTK examples hub, and so this stuff all builds out in Unity. But I wanted to go in and just check out some of this stuff, mostly because we get to play with the HoloLens. And so you'll see the camera over here, can't see what's going on in here. Implementing HoloLens's spectator mode is like really difficult. It's really difficult. I've had Microsoft people try to help me do it, and even they didn't know how. So it's maintained by one guy. So not a lot of experiences like this yet have a 3D component. The one I showed you in the very beginning, they have an entire netcode component that actually syncs up two or multiple 3D worlds. So that's currently the sort of default way to do multiplayer stuff. There's nothing built into these headsets that really solves that for you. You have to do it yourself. But if we're thinking about just designing something, this is just full of a plethora of scenes that you can take and repurpose for your own desire. So you've got all these different kinds of elements. You have buttons. And this is a really fun space because you're going to get to see, and I wonder if more questions will come up or if this will help answer some other questions about, when you're looking at the difference between a 3D button, right? This is an actual 3D rendering of a button versus more 2D types of things that you can view from the edge on versus, being able to take a look at shapes. And this is what I mean by shapes that survive being looked at from any way, because you never know exactly which way you're going to have your user be looking. The other thing is you're never going to know exactly I should rephrase that. You have to write handler code in order to make sure this stuff displays in the correct way. And this is another challenge area that makes this technology still in the more the research phase, or at least smaller applications phase. Because, for example, you'll see part of this demo is inside my monitor. It's on the other side of it. Because when this loaded up, it loaded up with whatever position I'm standing at as 0, 0. And then it just loaded all the content because it doesn't have any intelligence of how to position content. And that's something that you have to actually take a look at the meshing data. And I hope that it'll load my meshing data for me. No, maybe not. There it goes. So you have to actually take a look at this meshing data and then start writing rule sets that say, either given that it's a floor, and there are starting to become some semantic parsing is what it's called, where you can say, given the floor, put something on the floor. But that's still a Wild West area too, where you might have to say, and you'll find a lot of Magic Leap games make you go scan the entire room. They make you do a mini game of walking around your space and scanning it just so that you're able to effectively participate in the positioning of the content, because they don't want content to end up inside your walls, right? So now you're starting to see with the occlusion mesh on, that content is behind my monitor. And that's a very recursive, trippy graphic here where I'm looking at myself looking at stuff. But I'm just trying to show you that you have to be really careful where things get positioned because it can become uninteractable. I can't interact with that because it's spatially located. I'd have to actually reach over my monitor. Oh my God. And then there's a crazy error where it comes to me. So there's a lot more consideration with these types of systems. And I think that's why VR is further along than this type of stuff, is because this type of stuff requires a lot more thinking and a lot more testing. And I don't want to say that VR is easy. I just want to say that this stuff is really hard to do effectively, to do it really well. So you end up, this is a general rule for this type of design, is do less, put less in the space. Because as you can see, the more things you try to have, the probability of it sort of messing up and being inside a wall or something grows. So you need to have less things that are more impactful. And then also you need to give the users the ability to move things around even if it's in a manual way, so that they can fix it. Let's see, this does play little piano songs. So there's also, again, there's lots of different interaction modes that are inside this. For example, scrolling a 2D plane with your hand. So like here you go, you have the HoloLens' equivalent of multi-touch, right? Where it's showing that it's kind of hard to use, where you're wanting to zoom into something and pan it around. So this, I really highly recommend. Grab the Mixed Reality Toolkit if you haven't already used it. It builds out onto a couple different devices. So if you have anything, you can also use it in the Unity play mode. I'm not going to demo this for you right now because booting up Unity would take longer than your class. No, I'm just kidding. But kind of kidding. But you can use it in play mode as well. But like I said, you really want to try and use this stuff in 3D. And that's why it's also taking a long time for this technology to become mature, because the access to the technology kind of determines the speed at which you can make it, which is a little troubling. It's really, you're genuinely adding a new, and I'm sure you VR folks know this, but you're really adding another dimension. So like seeing this happen here, you aren't able to understand, in a 2D way, you're not seeing that it is actually another dimension of closeness. And here I can get really close and I can make my eyes cross and all these types of things. And these are all the kind of usability pieces that you really, unfortunately, you can't hack it. You have to really try to build with these technologies, or else you're not going to get it right. So, and let me know if there are any other questions coming in. I think I'm gonna maybe pull up another thing, and I appreciate you guys kind of hanging along with me as I go through this sort of scattershot demo type approach.
I think this MR toolkit's really interesting to look at from a user interface design perspective, because when the platform owner creates a library of devices and interfaces, it gives you as a designer a toolkit that you can use straight away to prototype. Last semester I taught a class on virtual reality where the students used Valve's VR toolkit, and so it immediately gave them teleporting, picking up objects, throwing objects, all the useful interfaces that they would want in VR straight away, and it lets them focus on the content and not have to worry so much about designing the user interactions. However, I must say that you're right, that mixed reality is a whole order of magnitude more complex, because in VR, when you play something, it just works. It stays there because you have full control. But in augmented and mixed reality, the real world gets in the way, and the real world is messy and confusing and less reliable.
Yes, exactly. So that's why you really have to use these technologies. I would say that luckily you can kind of play around with it on things like the iPad. That tool I was showing you all before. Unfortunately, I think the other tool I was showing you is a beta of software. I think I'm using it through test flight, but I'll try to let you all know when that's available. But it's worth noting that MRTK does run on other, I think somebody's ported it over to Oculus Quest. So now that you've got hand tracking, you start to get these kinds of interfaces where you say, well, what if I put menus on my hand? And to build all this from scratch would take quite a while. So instead, now you've got all these different kinds of things that you can work with. So I really highly recommend using this. I've met the team that works on the MRTK. I would say of all the folks, they're the most committed that I've seen so far to making an extensible user interface set that's specifically made. What am I trying to say? They're trying to give you something that you could use to make applications, maybe rather than games. Although I think a lot of these mechanics you could easily incorporate into games. But if you have an interest in wanting to build systems that are for, I don't know if the term serious games is still in use anymore, but like if you wanted to be able to build an application that was more for a business use or something, this would be a really good place to start, because you're going to only get the sort of raw interaction. You're not going to have to deal with some of maybe other flourish elements, because as another piece to this is that you want to be careful with your, let's see, there you go. There was an error. As you guys, hopefully you got to see that it forgot where it was for a second and it drifted and then it came back. You need to be careful with your system where you need to give it, and these are great examples. You need to give it some sense that it's happening, but you can't overwhelm your user too much, because like you were mentioning, Connor, is that this stuff is in the real world. So also what I'm seeing right now, it's covering my view. So if I put like a bunch of explosion particles all over it and stuff, I would have a hard time seeing. So it's important to make sure your systems signal their state, right? If you can see, there's a really subtle glow that goes on here where I'm hovering, and then I actually make connection. So I think it's a little light on my finger actually, and then I make connection, and then I interact, and then I release. So that was effectively, as far as as a fellow designer, I would say this is a really effective type of a button, right? It doesn't do anything more than you need it to, but it does show you enough to know that, hey, I am hitting it. And that becomes really difficult to deal with when you can't feel anything, as you all know. A controller is actually a lot better because you could put some haptics in there, whereas this, you got nothing. So all these interactions that I'm doing here, these examples, they're really dependent upon audio and visual cues. And I don't know if you're able to hear the audio component, but I would say that also it's really important, and I've had to learn this myself being more of a visually oriented designer, that the sound component of this stuff, it really matters. It really helps the users understand that they're doing something or something has happened to have a sound. So these kind of go boop, 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 boop. They give you that little sound. So again, you can see this is all for us to use as designers and developers. So I really encourage everybody to check out the MRTK examples. And if we can, it's a bit of a weird moment in the history because all these kits don't really work together yet. If you're more of a Unity whiz, you can make that happen. But if you're kind of a mere mortal, like I sometimes find myself being, you have to kind of pick and choose which kit you use, because the libraries and the dependencies can get really overwhelming to try and manage. But I hope that will change, and I encourage you all to dive into these kits and kind of hopefully improve them. I don't know if any of you in the class are like more you lean more toward being more programming oriented and like to contribute to these projects. But this is on GitHub, and these other projects are on GitHub. And if we could get to the point where all these kits work together and we had one general repository of all the great knowledge for how to make this stuff, I think we would also be able to move this stuff a lot further along. And this is an example of eye tracking. So eye tracking is a whole other beast that I'm only just starting to understand. And I'm just speaking for myself. I think there are others in the world who have done a lot of stuff with eye tracking. The hardware has been really expensive. So this is also, if any of you are also researchers or you fancy yourself to become scientists or anything like that, it's worth noting that these headsets are about half as expensive as the cheapest eye tracking setup that, like my friend who got his PhD in learning analytics, they would use special hardware to track people's eye gaze. Well, he could have bought at the time he couldn't, but now he could have bought a HoloLens 2 for half the price, a little under half the price, more like a third the price of the cheapest eye tracking array. So this technology has a lot more crossovers than even just making actual applications. I think there's a lot of value that's going to be had here in analyzing people's behavior using these types of things. So for example, watch it, there it goes. Let's see if I can start a recording. Look at your eyes first. Okay, start recording. And then I'm going to look around and you'll see it build up a heat map. So again, these types of things for studying the real world are really fascinating. And we're going to, at Avatar Medic, we utilize this technology to be able to understand better how doctors and how first responders and how nurses interact with their world. Because you see, when I stare at something for a while, it builds up a heat map. When you mix, it's one thing to study a VR interaction of heat, an eye gaze tracking. It's another to be able to say, we can take the actual reality that we're in and then overlay this kind of a tracking system on top of it. This HoloLens 2 and the Magic Leap have really opened up a whole new door for understanding how people perceive their world that I think not a lot of people are talking about. But I'm really interested in it, because once you get your users into these types of headsets, you gain a whole new level of access to what they're looking at, which is why privacy becomes a really daunting thing, actually, for these devices. And I think that there's going to need to be a whole conversation around who gets to own the attention tracking and eye gazing data for all this. But for now, we're still in the Wild West days, so just implement something and we'll figure it out later.
We have a question from the chat. Joshua wants to know, does eye tracking take depth into account? Does it know if you're focusing nearby or far away?
It does. It does indeed. In fact, I wonder if I have an example that I can show. In fact, well, I'll just tell you while I boot up another, while I actually take a sip of water. Also, time check, guys. I want to make sure, I haven't really been tracking my time too well here. I don't know how much more time that we have.
You've been running for just a little over an hour, so it's been really good so far.
Let me talk about the eye tracking really quick. I don't have a demo that I can show you, but I do want to tell you a story about eye tracking. So I was working on a project, and I'm still working on this project, where it's kind of like a meditative healing experience. It's really cool to be able to see some of these like sacred geometries and these things show up. And I wanted to use the eye tracking. This was one of the first times I ever used the eye tracking on the Magic Leap, and the HoloLens has a very similar one. So yes, it does take into account distance or your convergence of where you're looking. And what's really weird about that is that if you notice in the previous thing, the demo I showed you with the heads up display, the icon for the eye tracking was a simple kind of a circle where the middle is cut out. This was because in my initial testing, and if you get to use eye tracking stuff soon, you'll all get to experience this. If you make like a dot be your eye tracking cursor, so if you have a cursor for your eye tracking, you'll look at it and then it'll get closer to you, and then you'll look at it and it'll get closer to you, and it keeps getting until it kind of feels like it hits you in the head. And it's a really weird experience. So you actually have to be really careful when you use eye tracking, because if you show the user all the time a cursor, they'll just look at it and it will effectively break the eye tracking, because they'll just constantly be looking at the cursor and getting closer and closer to their own eyes and basically kind of going cross-eyed, because they're trying to look at this object that's in front of them. And then that means they're trying to look, get closer, closer until it hits in the face. So you have to be able to signal that there's eye tracking behavior going on, but not just show a pointer. Because if you just show a pointer, you're going to confuse your user. So that's a good question. But currently these devices, they do a pretty good job of finding out how far into a scene you're looking, in addition to, so they have X, Y, and Z, I guess you could say. Any other, I don't know if there's any other questions. I'm just going to have some fun here now and kind of end the day with this drawing, which is my most favorite demo because it's interactive. And maybe I can try and answer some of these questions using this tool. So really, I mean, keep them coming, everybody. If you have more questions, I'm super happy to answer them. It's really funny to give a lecture to people, and I don't know, I can't see any of you. I don't know anything about you. So I'm just kind of speaking into the void, and I hope you're enjoying it.
They're all still here, so yeah.
Okay,
your audience is still listening. There aren't any more questions at the moment, but if you could show us some drawing, that'd be fantastic.
So this I really highly, I love this little application. Is one of the first things I show people, is just to be able to draw in space like this. I'm just going to load it up. But I'll say that there's lots of different games and things and stuff, but I have to say, as someone who's now used these types of headsets for a better part of almost 2 years now, because they've been out. So we don't count HoloLens 1. It was so, I don't want to say it was low quality, but it was very limited. And so this type of stuff really opens the door, because now you're getting much more robust type of paradigm going on here. But the things that make me return to this stuff over and over again are not the games. I don't really care about the games. I like games, they're fun, but when it comes to everyday, why would I have one of these types of computers? Because there's been a lot of, people are wondering, well, why would I have one of these computers? What's the point? And from my perspective as a designer, especially as someone coming from also when I was younger, making physical objects, is, in fact, this may be where I can do a final demo of the robot, because with this type of stuff, for example, like I was able to, like, I'll show you quickly. My little cursor is going to be offset. So actually, this is a good opportunity to talk to you all about. If you see this, I have my avatar here, and then I have I'm offset from it. So in order to create these types of experiences, some of you may already have had experience with building multiplayer solutions, but this is a big frontier area, is that you need to coordinate a stage anchor, as it's sometimes called. Well, let me actually show you what's happening from my side. So I have set on the iPad a location that is considered the world origin. And then in this other side on the Magic Leap, I need to set a very similar world origin. And there's a couple of different ways to do that. You can do it manually like this. You can also use an image anchor, so a piece of paper that will link them together. And that sometimes is more robust, but then you have to have a piece of paper, which is kind of funny, to have to carry a piece of paper with you for your special space computer. So I'm gonna move wherever the iPad's little. So you see, you kind of have to. There we go. Maybe that's good enough. Am I a little closer now? You have to synchronize where the two worlds are, and it makes it a bit interesting to be able to build these types of things. See, if I go down on the floor, then I rise up to the top. So I've actually experienced this, and I'll share a link as well to you all to some videos that I have of me using this system as avatars in this mode, where you can meet with someone and draw together in space. But I have used this in like my daily life. I will do silly things. They seem silly. Like I'll measure out the size of my monitor or some kind of picture, and I'll do it in context. So now I traced my monitor. This is the spatial drawing of my monitor where it was 1-to-1. So I have now this object which represents the size of my monitor. So I could go, or I could have a picture frame or whatever it is, and I can go and like put it in space to figure out if it's the right size. So that's why it's called a spatial computer, as opposed to something like augmented reality, which functions more like what you're seeing now, which is really just an overlay on top of video. If I put this behind me, see on my avatar, it's occluded, but on me, did it lose tracking? See, this is also the trick with this stuff. If you put it behind me, come on, there you go. It doesn't go behind me because I don't have a body mesh right now, but my avatar does. So you can see that we're still in the really early days of this technology, where it can sometimes seem a little bit more primitive than it actually is when you're viewing it in 2D. But rest assured, this is a fully spatialized drawing experience. And I have to say, it's just super fun and actually really helpful, because you can actually imagine designing something where you're able to, let me see if I can, there you go, give you the both-sided context, where I'm able to, like, say, oh, okay, I want to make a table. Oops. Come on. I want to make a little table. Let me use my straight edge, and I want it to be this tall and whatever, and then I can see, is it going to fit in my space, etc. And here's also, just because it came up, an example of using the hand to bring up an interface element, and then you're going to interact like this. But if you can see from my screen on their side, this is not my favorite interaction paradigm. I think you'll have to be careful. And if you want to build for these types of systems, what we learned pretty fast is that although these types of interfaces might look really natural, they can get really tiring to use over time. So maybe I can conclude by saying that don't make your interfaces like Minority Report if you expect someone to use them for more than 20 minutes, because you've probably already heard of Gorilla Arm, but it's real. And especially when you're dealing with these types of things where there's a real world around you, you want to try to avoid making the graphics. You don't want them to become too overwhelming. You need to be careful with how much of them there are because they cover up your world. But overall, this technology is probably at the, sometimes I say it's like at the Macintosh stage, but it's probably a little bit further beyond than that. It's probably more like at the Windows 95 stage, maybe a little bit earlier still, where we're not quite sure exactly what this is going to do. We're still figuring out a lot of the paradigms, the user interfaces, and all these things. And the technology itself is still kind of primitive, but it works. And it does let us build things that at least give us a chance to verify assumptions and get the buy-in from the right people to be able to continue building these things.
John, I found the same experience using Tilt Brush in VR, which was that the user interface looks beautiful and is really nice to use at first. And after about 40 minutes of drawing, your arms are extremely tired. The weight of the controllers was actually a major factor. The weight of the VR controllers prevents long session use. And I think you probably find as well that the weight of the headsets eventually becomes an issue. But as we move to finger tracking and using pens and using lighter glasses, I think those issues are going to go away as the technology matures.
I definitely agree. That Magic Leap gets really hot on your head. And I would say that this HoloLens 2 represents the first one of these headsets that I could wear all day. I have worn this all day while I've been building for it, and I don't feel like my head's going to fall off or anything. It's pretty nice to wear, and I always do the spouse test. I give it to my painter spouse and see with each of these technologies. And this was the first one. She put it on. I put it down for her like this, and then she started, doodling around and stuff. And she didn't really think about it. Whereas the Magic Leap, it was this whole thing. In fact, when I talked to Magic Leap's, and I'll send this link to you, I have an interview where I used Magic Leap's avatar system they have built in to talk to the designer of their avatars. So I spoke to her as an avatar, and we talked about their design philosophy at Magic Leap, which was more about you entering a virtual world. So Magic Leap kind of similar in a way to VR in that you're going to put on, they called it putting on your commercial space gear. And whereas HoloLens, they deliberately made it much more like a hat. I tell people it's like putting on a baseball cap. So in fact, here, I'll show you my favorite feature. Oh my gosh, you can wear glasses, which you cannot do with the Magic Leap. So overall, this is a really exciting time for this technology because I've been tracking this technology for almost a decade, just personally. And this is the first time when you can actually build something for this. Previously, if you wanted to work on this, you were either going to do it in theory or you were going to work at a government lab where they have a $90,000 headset or some kind of a thing that goes through to the F-35 fighter jet, which does have, the F-35 fighter jet has a heads-up display system that can see through the plane, and it's basically a really expensive HoloLens in a lot of ways. But I think, this is something that came up actually with another one of your students, Connor, Jack, that we worked with, was this transition from you may think that VR, you may or may not think this, but a lot of folks, I think, still view VR as something that's about games. It's like another console, and that Unity is a game engine. And that's true, but it's also true that you can use Unity and the same skills you're developing in this class making games to make, and that's what I was hoping to show you today, is that all this stuff was made in the same universe of tools that you would make a game. You can also make applications, things that are meant for doing something. And I hope to encourage more people who are in school learning to think about their future in this industry as being part of games, but also potentially being part of like serious applications, because right now these devices don't have a lot of content that is useful. They're kind of, HoloLens is a bit of an exception because they want it to be useful for their customers, Microsoft, right? They're a big business company. But a lot of the things that we use on our computers every day, nobody's made that thing for, even for VR, but let alone for something like a Magic Leap or an Nreal glasses is another one that are relatively, I say relatively inexpensive because they're, half the cost of this. That's still expensive. But, when I was in high school, the iPhone 1 came out. And the iPhone 1 had no apps and it sucked. But then within 3 years, at least in my community, if you didn't have some kind of touchscreen smartphone, you were at a major disadvantage. So I would say, maybe this is my concluding statement, is take a look at how to bridge your game making or maybe your more creative abilities with how to build commercial software. And I say that maybe not commercial software, like boring software, back-end stuff, but more of like, how would you make something that would be useful to a lot of people, or make something that would be interesting to people more in a way where they would interact with it like an app as part of their daily life. And I think the sooner more people think about that, the better they'll be positioned for when these technologies become the next thing, where if you're not wearing this, you will be at a disadvantage. Not this is a big clunky thing, but eventually these are going to get to be this small. Probably, if Facebook has anything to say about it, that'll happen within 3 years. And then you will have a new paradigm on our hands, and all of your skills of developing 3D content will become really in high demand, because as some of you may know already, 2D skills don't translate that well. And I mean that with the most love and respect, because I'm a 2D guy. I came from photography and 2D user experience, but I had a lot to learn to get into 3D, and I'm still learning a lot. And that even just means the technical specifics. So the sooner you can think about what will become a future industry, or is already becoming an industry, and it comes with games and a few other applications, especially now with COVID, there's a lot of push to be able to get us out of Zoom meetings and be able to figure out what does the future of being together look like. And so I think maybe next time, maybe next year, I can give a lecture again to this class and we can actually all be avatars, because the technology, and that's what this will actually conclude, is that this is a weird time because I can be an avatar, but nobody else can. So the technology is still very hard to come by, but I think within 3 to 5 years, if you're in a privileged area, a developed area, you're going to be able to have access to this, and you're going to want to do it. Don't be those people who are like, well, what's the iPhone? I don't care. Because my impression is our professional users, our medics, firefighters, the people we're showing these systems to, they are really excited. They know it's not ready yet, but they're really excited. And so I think that if people like that are excited, they have a reason to be excited, because they have a lot of information, they need more knowledge, they need more content. But I think even regular people are running into the limits of our screens. And so I think there's going to be a big demand for people with the skill and the vision to make useful mixed reality spatial computing applications. And it's going to be like almost a flip, where people are going to be like, Unity, that's for games. And so that's just why Unity went public, right? It's because they're about to be worth quite a lot of money. So these are great skills to have. I'm happy to answer any last questions that might be here. Maybe I can do it quick. I don't want to.
John, it would be great to have you back again when we have access to our HoloLenses. This, without the COVID lockdown, this would have been a course where everybody was doing mixed reality on HoloLens hardware. One of our students, Tung, has just noted that these things cost $5,000 on the Microsoft Store, and is wondering, do you have advice for how they can get access to this equipment at a low cost or outside of college?
Yeah, it's a great question. This is probably the most useful question. If you're in a place where Microsoft has a presence, you can go to a place called the Microsoft Reactor. I haven't looked up whether there's one in Sydney or anywhere in Australia. Luckily for me, I'm in California, so there's a lot of these. or at least there's one in LA and there's one in San Francisco, I was able to use the HoloLens to build entire applications, basically borrowing it from them at their reactor facility, even before anyone could buy these things. They had, in fact, we were using like version 2 of the HoloLens 2. So now it's like I think the version I have is like version 36 or something. So we were using like really early hardware. So that's one way to do it, is if you can try and find access to the companies. The other way is that there are other hardwares, like there's the Nreal. I'm pretty excited about Nreal, but I'm going to give you all some insider tips about the way that politics and technology intersect. Nreal glasses, you may have heard of them because it's notoriously that he was part of Magic Leap and then he left, and it's spelled N, like the letter N, real. And they're much cheaper and they pair to a mobile phone. And it's really great. I've looked through them before. They look pretty good. They're not as advanced as Magic Leap. They're not as advanced as HoloLens, but they're much cheaper. The problem is, for me, building applications where I want to engage with the U.S. government and public safety outfits, currently the political situation means that if I use a Chinese headset, I have problems later. So this sucks. But if you're making games and you're making other things, I would really seriously look at stuff like Nreal. And I think there's going to be a few others that are going to come out that are actually use your phone as the computer. So you don't necessarily need to get a HoloLens 2. That's like the pinnacle one. It's a very advanced piece of technology. It works really well, but you don't need that. And then I would also say that right now I have the iPad in front of me. That's my webcam. There's another app that's called Torch. I don't have time to give a demo of it right now, but that you can download that app, and that actually lets you prototype on the 2D screen, kind of interactive AR spatial computing experiences. So that's another way where, like I was saying earlier, there's two components to this. One is like the spatialization. How does the computer know about space? And then the other is the actual depth, like where you're seeing how far away something is. Even if you just experimented with the spatialization, you would still gain a lot of insight. Although in order to get to the depth, you have to have the headset. So the only other thing that I could say is that if you all have access, there's only one other thing which I really recommend doing. I'm going to do it myself. I just haven't had the time yet. Is to actually, you can print your own headset. You need to buy a couple of components, but it's called Project North Star. It was actually started by Leap Motion, and it's not as well known as I wish it was, but it's a totally open source design for a headset. And I'm talking a headset that's like the HoloLens, and it's actually a little better because it has a 100-degree field of view, but it's like this big on your head. It's like a huge thing that you have to wear and plug into a computer. And it's very hands-on. It's not a product. But as far as getting access to this stuff, the only other thing would be the new Oculus Quest. It sucks that it's Facebook. I'm just going to say that. I'm going to say that on the record because I think that a free and open web is essential to the future, and Facebook doesn't do that. They're a platform. It's not bad. It's just potentially dangerous if you're trying to build an entire thing. But putting that to the side, their hardware is really great, and it has pass-through. So if you have access to an Oculus Quest, or if you want to get a new one, they're $300 American dollars, and they're probably going to sell out right away because they're really good hardware. But they have access to pass-through, and so that lets you experiment with, there's the two kinds of doing augmented reality, or sorry, I should say spatial computing, is you can do additive display, like all the technology I've been showing you today, or you can do pass-through, where you take video feed from the outside and you add graphics to it, and then so it's a composite, and then you put it back onto your face. There's a really expensive one that does that called Varjo and has certain benefits, but yeah, hopefully that answered your question a little bit and gave you some leads.
Thanks, John. Hopefully the hacker community will get behind the Quest and enable it without a Facebook account. That would be very useful.
Yeah. I mean, I just made a fake Facebook account for the first Quest, but I don't know if they'll.
Yeah. Well, I've heard a lot of stories of people who had cancelled their Facebook account and can now no longer use their Quest. And
Yeah.
can't create a new Facebook account either, because Facebook literally require one account per human. You're not allowed to have alternate accounts.
Yeah. This is something I just got working a few moments ago. And so I'm going to make sure let's see if I don't break it. But this is a robot arm from a company called Haddington Dynamics. And this is Unity, a project that they provide where you can control the system. So what I'm going to build over the next few weeks is an interface for this robot where I can use the HoloLens and move its arm and then move the robot. Because this is where the rubber's meeting the road for us building our humanoid telepresence robot, and we're going to control it in a Unity-based system. So this is why I wanted to bring it all together here and say that these technologies are not just about virtual things, they're about controlling physical things as well. So I'm gonna move, I need to go into play mode. I only just figured out that this will work today because
I hope this works.
So all I'm gonna do is proof of concept for you. I'm going to move this end effector forward, and I'm going to hit space. And you hopefully will see that it did it. That's it. It's so simple, but I can move the end effector. And so inside of Unity, I am controlling this. And so Unity is here being used as the interface for this robot. So now inside of there is an IK rig. So again, this stuff is really important. This isn't just about virtual worlds. This is about, there's going to be a merger that's coming on right now of the physical world and the virtual world, and they're going to gain the best characteristics of each other. And it's often called the mirror world by people like Kevin Kelly and others. And so this is pretty far out stuff is happening right now. So you're all at the forefront of something that maybe you know this or maybe you don't, but it's really big. This is one of the biggest technological changes that's gone on in the last, probably the 50 years, because now something like, robots and other things, they can all be addressed from the same interface in a 3D way. And I like to say that we've never had 3D drawing or anything before other than sculpture. We always had 2D screens that can now represent 3D graphics, but they're not actually 3D. So now with VR and mixed reality, we actually have a genuinely 3D, actually 4D medium. And that means we're going to be able to do things that we actually can't imagine. So that's why I think it'll be essential of, even if like a bunch of you wanted to buy a headset and you like rent it to each other or something, I would say that if you're passionate about this, try and do whatever you can to get your head in there as soon as possible, because it does make a difference actually seeing the technology versus just thinking about it. So that's it. I'm done. Thank you all for your time.
Yeah, the students have said this is really helpful information. One of them has noted that there is a reactor in Australia. There's one in Sydney.
Okay. Great.
And someone else has commented that perhaps they'll get Linux running on the Quest. That would be really good. I want to thank you, John. This has been a really useful and informative talk. I thought your format was great. I'm really impressed with the robustness of your various streaming and capturing, and that everything actually worked smoothly.
It actually worked. Yeah, I appreciate you all being here with me for this. This is, like I said, the meta theme of this, hopefully, is to show you also that if you have 3D and your audience only has 2D, don't let that stop you. You can still use it to your advantage.